Hello everybody, my name is Parson. Welcome to our channel where we build your path to toppers. Today we are starting our brand new series on this channel, Grade 9 Math. In this series, we are going to be covering all the chapters in Math Makes Sense 9 textbook. So the first chapter we have in front of us is surface area and square roots. This chapter has been divided into two parts in your textbook. First part is how to find surface area of different 3D composite objects, and the second part is square roots, how to find square roots of perfect, non-perfect squares, of fractions, decimals, etc. We're gonna have this chapter covered in 6 different lectures. First 3 lectures are going to be about surface area, and the next 3 chapters is going to be about square roots. So today we're starting our first lecture on surface area. Let's get started. So before getting into some calculations and formulas, first we are going to learn the definition of surface area. Surface area is something we can touch outside a 3D shape. So let's take this as a cylinder and let's apply the definition on it. It's something that we can touch outside the 3D shape. Now this is a cylinder and we can touch the curved area from the top to bottom, we can touch. And then this 2 circles at the top and at the bottom, we can touch that. So that's what basically surface area is. If we know the radius of the circles at the top and bottom, through pi r square we can find out the surface area of the 2 circles. And then the curved area, if you just imagine, if we open it as a 2D shape, is basically a rectangle that we just curved it all around. So if we know the length and the height of it, we can basically take out the surface area of this rectangle. And one more thing that is not in our syllabus or in the textbook, but PATs a lot of time they put this word in some questions just to make students confused. It's volume. Volume is not, we're not supposed to know what volume is or like take a volume of a 3D object, but we're just going to take a quick look at the definition because a lot of times PATs put in our questions and we get confused about what does it mean. So volume is how much space an 3D object occupies. So if this is a cylinder and it's in a room and it occupies a space. Now, if I put 1,000,000 pens in this room, there will be a limit where I just can't fit any more pens because all of them each have a particular volume which they occupy. So this is what basically volume is, and we just need to know the basic definition of it. Now, in our lower classes, we learned how to take a surface area of 2D shapes. Now basically, this is a square, and a square basically has both same length and breadth, so we just call it AA. And if I ask you to take out the surface area of the square, you'll basically say, this is so easy. It's A times A. Because both of its length and breadth are same. It's A times A. And we can just call it A squared. So this is what we learned in our lower classes. And then in last class, in grade A, we learned how to take a surface area of 3D objects like cube or cuboid. Now we know that cube is made of different squares joined together. Now we can see that since they're square, all of their sides are same, A. And now if we take the first square in the front, the length is A and the breadth is A. So it's A squared at the front. And it's same at the side, same at the top. Now we can see all 3 of these are same. Now, is that all? No. Since this is a 3D object, we're gonna see it from all 3 dimensions. This is just what we can see from one side. But if we imagine there's a back side, we can just see that if there's a top square, there should be a square at the bottom. that is also a square, and all the other sides are a square. And all these faces are six squares joined together. Now, if single square is a square, this is basically e to the power 6, which is pretty easy. This is what we learned in grade 8. We learned cuboid and many other 3D objects. But in grade 8 or even till now, a lot of people, like me too, I had a confusion that what is like when I was in lower grades, I used to take out area of a 2D object. I was supposed to take out the area of the square. But now when I'm in grade 9 or grade 8, they call this surface area. Like, is there a difference? There's a big confusion a lot of people have that what's the difference between surface area and area. Area is basically area of a 2D object, and surface area is the same thing for a 3D object. And it's basically because 3D objects have a lot of surfaces. Like, I just like this way to remember the difference. It just has a lot of surfaces, and we combine those surfaces, multiply it with the area. Area is of a 2D object. So that's a big confusion a lot of people have, even when they are in grade 9 or grade 8. So this is what we learned in grade 8, just taking out the surface area of 3D shapes, which was pretty easy when we know formulas or know how to take nets. We'll learn about nets and imagination in our second lecture. For now, this was pretty easy. But what are we actually going to learn in grade 9? In grade 9, they're asking us to take out the surface area of combination of 3D shapes. Now, if you're thinking what's combination of 3D shapes, it's basically two or more 3D shapes combined together to make a new shape, and they ask us to take out the surface area. Now, for example, we have a cube here and a cylinder on top of the cube. Now, a lot of people just think that how are we supposed to find the surface area? There should be a formula for it. But there are endless examples that we can combine these two shapes with each other, and there can be endless formulas. So what we like to do is, if they give us the radius of this top circle and they give us the height, and we know the area, like the side of this cube, which is A. So if this is A, this is A, and this is A. So there are a lot of different ways people like to do. Some people like to take out nets of both of these shapes, then subtract the top one from the circle. Because if you imagine, the definition of surface area was something we can touch outside a 3D shape. Now, if I consider the top circle, I can touch the top circle, but the bottom circle is glued to the cube. I can't touch it. I can only touch these curved corners. Now, there's no formula for curved corners. It's pretty complicated. So what we like to do is, since the top is a square and this circle is pi r square, we subtract it and we get this all the sides, and then rest we just keep it the same and simple. So this is how we find the surface area of combination of shapes, and this is what we're going to be learning in our today's lecture. We're going to have all the formulas for different shapes, 3D shapes. Just a quick recap from grade 8, because a lot of people just don't remember simple formulas like a square of a cube. And in next lecture we're gonna take out nets of 3D shapes, and then our third and final lecture we're gonna have practice questions, something like these, to actually you to practice those questions and get better at different 3D shapes and their combinations. Mostly in grade 9 we only have two shapes combining. It's a rare case that we have two or more, but some of the questions that I'm gonna show you is just a pyramid, but it's made with different pyramids, 1 2 3 4. So 4 pyramids combined together to make a big one. So just taking out of confusion that most like these questions only have two shapes. There's some rare questions like these that we're also going to cover, which have a more or two or more shapes. But it at the end, it's basically one shape. So these questions are way easier than people think. Actually, are make a very big confusion that these shapes are pretty hard to take up. So now let's quickly take a recap of all the shapes and their formulas. And since this channel is made to understand, not to memorize, we're gonna understand all the formulas and how they were made. So now we have all the formulas written down here for our top four 3D shapes we need to know. So these are four shapes we need to know: main, triangular, prism, cylinder, cuboid, and a cube. So we're gonna recap all the formulas of these four shapes that we need to know for our surface area and square root chapter. First of all, we're gonna know all the TSA, total surface area, like how to find the total surface area of these four shapes. These are all the formulas. And then CSA and LSA, the full form is curved surface area or lateral surface area. For shapes like cylinder, we use it as curved surface area because they're curved from the sides. And shapes like cube, cuboid, it's called lateral surface area. It's the same thing because we are taking the sides and front and the back shapes, concluding to lateral surface area. So first object that we're gonna take is cube. Now cube, lateral surface area of cube is basically the side. So we don't take the top and the bottom part. So if each square is a square, because it's a times a, like the length and the height, and then we have one at the front, one at the back, and two sides. So it's 4a square. So this is how we can imagine all the formulas. And then for cuboid, it's we're gonna take it as the front is length times height. So it's L times height, and the same as the front, the back is also the same. So it's 2 and then length times height. LH is in the bracket. Then for the sides, it's breadth times height. So BH, and then there are two sides, so 2, and then we add them. Now just to make the calculation simpler, we take 2 and h common, so it's 2 times length plus, because there's a plus sign, breadth, and then h getting multiplied with whatever is in the bracket. Then for cylinder, it's the curved area. Now it looks pretty complicated, 2 pi RH, but if you want to imagine it, let's say it's a ring, a circular ring. We have a ring here, and then the circumference of the ring we already know is 2 pi r. Sorry, is 2 pi r. And if I just combine more and more rings at the bottom till h height, because we know the height is h, and if I just keep on combining more rings till h height, it's gonna be 2 pi r h. So that's our curved surface area formula. Now it's almost same for triangular prism. The lateral surface area is all the sides, these rectangles here. So what we take it as, if we keep this a triangular prism upside down, like standing with L as our height, what we see is a triangle, and then like this, we have a triangle at the bottom, and then our main height is whatever L is, the length of the triangular prism. So in order to get that, we can follow the same method as the ring one. If I put more triangles on top of each other till L length, height, till L height, we can get all the lateral surface area of the triangular prism. Now how do I put the circumference, not the circumference, but the side area of triangle? It's basically just side one, this bottom part, and all the length, that's a slanted length, side 2 and side 3. If we add all of them, it's this kind of a perimeter of a triangle, and then we take it till L height. So we add all the sides, multiply by L. So these were our lateral and curved surface area. Now we are going to talk about total surface area. So for a cube, the total surface area is all the sides and their surface area combined together. So now we know that the one face of the cube is a square, and 4 faces is 4a square. And if we add 2 more, the top one and the bottom one, it's 6a square. So it's pretty simple for cube. And then cuboid, we can have the same thing we were having. The idea is we take all the sides as a rectangle, and then the front is same as the back, the side is same to the another side, and the top or bottom are same. So we just multiply them by 2. So it's basically the front is L times H, and it's the same as the back. So it's 2 times L times H. Then the side is breadth times H, same as the other side. So it's 2 times breadth times H. Then the top is length. This is the length, and this is breadth. A lot of people make a mistake that they do L times H for the top too, which is wrong, because at the top, if we just see a rectangle from the top, we can only see length and the side this is breadth, it's no height. So it's the same as bottom, so length times breadth. So if you take a common, it's length times breadth for the top, plus breadth times height for the side, plus height times length for the front, all of them combined times 2, because they're same from the other side. Then for a cylinder, we know the curved surface area, the this place wherever we can touch, not the circles, but this place is 2 pi RH. And then if you see what's left in a cylinder there we can touch, that's basically a surface area, is the cylinder at the top and the cylinder at the bottom. Sorry, circles. A circle at the top and a circle in the bottom. Now we know the surface area for circle is pi r squared. Now since there are 2 circles, one at the top and one at the bottom, we multiply by 2. So 2 times pi r squared, and then we add them. This is our total surface area for a cylinder. It looks a bit complicated, but when you practice all the questions that we're gonna do, it's gonna be easy. Then for a triangular prism, if you just have to find the total surface area for triangular prism, I would suggest making nets that we're gonna learn in our next lecture, because formula is a bit off for some, and like some objects, like if it's a right triangular prism, so it becomes a bit complicated. But if you just want to learn the formula, here it is. We know the lateral surface area is this, and we need to add the both triangles similar to our cylinder. So the triangle formula to a triangle is 2 times base area. Now one triangle is this, the front one. Now it's same at the back, so it's times by 2. But if you're wondering what's base area is basically 1 by half of b, the one at the bottom, this is called b just for reference, times h. H is our height, this, not the slanted height. A lot of people just take this, this is the slant height, this is hypotenuse. We take the base and this height, so we times 1/2 by base, so this much is 1/2, just half it, like divided by 2, and we get this times the height, which is our base area, which is the first triangle in the front. Now we multiply this by 2 to get the triangle at the back, and then we add it with all the lateral surface area to get our total surface area for a triangular prism. Now, a lot of people just make mistakes in calculations. So one of my tips for calculations in whenever you're putting formulas of different objects together would be, don't put on the values just at the start. Like if you want to add a cube to a cuboid, like you want to add these two, because we're combining two shapes in our grade 9 curriculum. So if you're doing this, try to get things common and simplify the formula. Like in this, we could have used this formula at the top, but just to make it less calculations, we took h and 2 as common, and we had a smaller formula which we can easily all calculate, because L plus B is easy, and then we multiply by h times 2. It's easier than just then also doing this and then this, then adding all of them. So this is my tip. If you're combining two or more 3D objects and you're just writing their formulas, first take commons, whichever you can, and then put on the values so that it's easier for you. Because sometimes even when we put it on calculators, it's pretty hard, because sometimes what I used to do is 2 times pi. Now if it's 3.4 cylinder, it gets complicated into decimals. So if it's 3.14 times 2 is 6.28. But if it's like a bigger decimal, if the calculator takes the whole pi, it might be a bit different. So my suggestion would be just take all common and then put into calculators. Now let's do some examples by using these formulas that we learned in grade 8, and then in next lecture we're going to learn about how to imagine the 3D objects and do nets. So now when we know all the formulas of 3D shapes and how to take out surface area of different 3D objects using those formulas, let's do some word problems to help us get more familiar with those formulas. So first of all, before writing the question, what I like to do is I write EP square, because EP square is basically EPP, because P square is P double P, and the full form is easy peasy problem, because it helps us trick our mind, just making sure that we think the problem is never hard and every question is easy if you try. Because I've seen a lot of kids just giving up when even before trying what the problem is or reading it, because they think the numbers are too big or different examples. So this is what I like to do. You can do it too. And now let's read the question first. We have a word problem here. A rectangular shaped box measures 120, 80 and 60 centimeter. Now one thing I would like to clear is whenever they give us the measures in 3 different columns and they don't tell us what's length, what's width, what's height, we can just imagine it's LBH, because every time if it's just commas and the numbers, it is going to be, first one is going to be the length, the second one is going to be the breadth, and the third one is always going to be the height. And then we have our centimeter, the measures, and this is a rectangular shaped box. That means it's a cuboid. And now it says the container is open from the top. So the cuboid, let's say if this dust tray is a cuboid and they're saying it's open from the top, so the top part is not there, it's open. And they're asking what is the total surface area of the container that needs to be painted. Now if the cuboid is open from the top, we can't paint there because there's nothing there, it's open from the top. So we can't take the total surface area formula for this, because the top part cannot be painted. Now let's first make the shape so that we can visualize it better. So if you have a cuboid here, and this is how a cuboid would look. I'm just making it with the top part, and we can just take out that the top part is not here, and our measures are, our length is 120, our breadth is 80, and our height is 60. So now we know the measures. So there are two different ways and many ways to take out the total surface area of this container. One of the way is we take the total surface area of this cuboid and subtract the top part from it, or we can either take the lateral surface area of this cuboid and then add the bottom part to it. It's the same thing, but I'm just choosing one. I'm taking the total surface area and then subtracting the top part. Even if you try with the other example, you will get the same answer. So if we have to find the total surface area for the container, not the cuboid, but this container which is open from the top. If we have to find total surface area of the container, we will need to take total surface area of a cuboid and then subtract top part, and we subtract the top part to get the total surface area of the container. Now we write the formulas that we know. We know that total surface area of the cuboid, the formula is 2 times length times breadth plus breadth times height plus height times length. This is the total surface area of the cuboid. Now we have to subtract the top part. Now the top part is basically length into breadth. So length into breadth. Now when I was teaching you guys the formulas, at the end I told you a tip so that you don't have to make those calculations that much big and complicated. I told you guys that whenever we have the formula written, so this is our formula for this container, whenever we have it written, we will try, if we can, to cancel out or take common. Now here what we can see is we're subtracting an LB and we have a positive LB here. We learned in our past classes a positive and negative cancels to a zero pair. So we can cancel a negative and a positive. But a lot of people make mistakes here. They just cancel it out and keep this times 2. But that's wrong, because here we have 1 LB and here we're multiplying it by 2. And so that means we have 2 LBs and one of them cancels out. So we have 1 LB left of positive. So our formula is going to be 2 stays the same. In the bracket we have BH plus HL plus, because we have a positive LB left, plus LB. Now we have a formula here, and now it's pretty smaller than the formula we had before, and our calculation will be way easier. Now we're gonna put all the measures in. So if we say it's 2 times breadth, we know the breadth is 80 and height is 60. So 80 times 60 plus our height is 60 times our length is 120. So this is our bracket, and then 2 comes down here. LB, length is 120, this is getting added, 120, and breadth is 80. So now if we do all the calculation, we will get the surface area of this container, not the cuboid, because we already subtracted the top part. So we're gonna get the surface area of the container. Now for these multiplications, I'll like to give you guys a tip that whenever you have 60, 50, like zeros at the end, all we can do is take the zeros and then multiply 6 times 8. Now 6 times 8 is 48, so we write 48 here. So this is our answer whenever we multiply. Like, I know you guys have calculators, but whenever you can do it mentally, try to do it mentally, because in colleges and universities you won't have calculators. And now this is this, and then 60, we write the zeros here, the same method. And then 6 times 12, 6 times 12, we know 72, so we write here 72. So we have 7,200 here in our brackets. Never forget to take off brackets, and because it makes your calculation go wrong. Then this here, we write the zeros, yeah, and then 8 times 12. Now if you know that 8 times 10 is 80, but how do I take out 12? So it's pretty easy. You can cancel it out, like subtract it. Now this is 10. If 80 times 8 times 10 is 80, and 8 times 2 is 16. So 80 plus 16 is 96. So we write here 96. So that you try not to use calculators as much as you can. Now 2 comes down here as the same. Now first we do all the brackets. This is our brackets. We add this, and we don't add this before, because after we are adding this, according to BEDMAS, we have to multiply first. Now 4,800 plus 7,200. If you just take it down, zeros, and then this comes 7,000 plus 4,000 is 11,000, and then this is 1,000, so it's 12,000 here. 12,000, one more zero, and then we have a comma here. Now this is all getting multiplied by a 2 but first, and then we have to add 9600. Now this is our calculation coming down to 12,000 times 2 is 24,000 plus 9,600. Now if we add 9,600, we're gonna get the surface area of this cuboid. So total surface area of the container is, if we have 24,000, 9,000 is 33,000, and then 600. So it's 33,600 centimeter squared. Don't forget to put the units, because your marks can be cancelled out. So this is our answer for this word problem. Now let's do some more complicated word problems to get familiar with those formulas and those calculations. So here we have our second word problem, and this is also EP squared, just helps you to trick your mind. And this is our second word problem, which we're gonna practice to get more familiar with the formulas. So let's read the word problem first. A tent is shaped like a triangular prism. Now it's a tent which is shaped like a triangular prism. The triangular faces is shaped like an equilateral triangle. So the triangle faced are equilateral, so the triangles are equilateral, all the sides are going to be the same. Measuring 6 meters, so all the sides of the triangle are 6 meters. The length of the tent is 10 meters. Now the triangle was 6 meters and the length is 10 meters of the triangular prism. What is the total cloth used to make the tent? So we have to find the total cloth used to make the tent. That means the surface area of the tent. But here's a trick in this question. We can't find the total surface area, because whenever you make a tent, like just imagine making a tent, there is no cloth on the ground. So we just have to find the two rectangles and two triangles, not the ground. So we can't find the total surface area. But let's first make the shape so that we can visualize it better. So if we have a triangular prism, something like this, So this is our triangular prism, let's say, and then our length is given 10 meters, and then these sides of the triangle are equilateral, so all of them are same. If one is 6, all of them are going to be 6, same as the back triangle, because they are all equilateral. Now we know the measures. What we have to do is find the cloth used to make the tent. Now the cloth is gonna be at the front, at the back, and at the side, the two side rectangles. But in a tent, you never put cloth on the floor, so we don't have to find the surface area of the cloth. A lot of people just find the total surface area and then they get the question wrong. So what we are gonna do is, we have two approaches now too. We can either take the lateral surface area, and then we can also take the lateral using the two triangles, the front triangle and the back, and then do the bottom one, like just take it out. But then we have another approach where we can just take the total surface area of the triangular prism and then subtract the bottom one. That's what I'm gonna do too. You can go with the second approach. You will get the same answer eventually. So we have to find total surface area of the tent, not the triangular prism but the tent, because the cloth used in the tent, because the cloth is never placed on the bottom. So in that approach, we can take the total surface area of the prism, and then we can subtract we can subtract the bottom. We can subtract the bottom part. So now we're gonna put our formulas. We know the total surface area for prism is length times side 1 plus side 2 plus side 3 plus, in bracket, this is all a bracket, plus 2 times in a bracket 1 by half base times the height. And then the bottom part is just base times the length, subtract base times the length BL. So now what we have to do, before putting in all the numbers, we know that we don't have height. Now a lot of people just get confused that what is height. In a triangle, height is something that bisects the triangle at 90 degrees, having the base 1 by half. So this becomes 3, this becomes 3. Because now height is not this. This is slant height, this is hypotenuse. Height is this part, and we don't know that. So what we have to do is we have to use Pythagorean theorem that we have already learned in our classes in grade 8 to take out the height, and then we can use it in a formula. So for that, let's see. Our leg is 3 squared plus, this is, let's say, just x squared equals 6 squared, because 6 is our hypotenuse in this right angle triangle. And if we take it out, move this to other side, so x squared equals 6 squared minus 3 squared, and x squared, we have to remove the square, so this is under root 6 squared minus 3 squared. Now if you put it in a calculator, we put this in a calculator, we will get 5.196. This is what we'll get. Or we can just extend it to more because there are more decimals, but let's just keep it this. This is our height of our triangles. Now we can put all the measures in. Our length is not this, this is base. Our length is this, so 10. Side 1, all the sides are same, so it doesn't matter, we just write 6 plus 6 plus 6, then add, then this is 2 one half our base. Our base is like the whole base is 6. Then our height that we just took out is 5.196, and then this breadth base is 6 times the length is 10. And so now the only thing left is calculations. So now our calculation is going to be pretty easy, except this you can just put in your calculator. This is 60, subtracting this 6 plus 6 is 12, 18 times 10 is 180, then plus 1 half of 6 is 3, 3 times 5.196 is going to be the whole thing times the 2, so we have 31.172. So this is what we have after this whole by timesing by 2, and we have to add, subtract. Now you can do it either way. Whenever you do bed math, you can know that you can either do addition or subtraction. It's on you. And then now we have, now this equals 1.1772, and then subtracting is, we're subtracting 60. This is our total surface area, by the way, of prism. And then since we need total cloth used in the tent, we're subtracting BL, which is our bottom surface, because we don't use cloth in our bottom surface. And this will equal to 151.18 meter square. I just rounded it to 1/8, and this is our total surface area for prism. Sorry, not the prism, because prism is this, and then we subtract the 60 because we need the cloth, so it's total surface area of the tent. So this is our answer for this EP square word problem, and you guys know this was pretty easy. If you keep on doing practice more and more, you will eventually find this pretty easy. We'll do one more question based on cylinder, because we did cuboid and now we did prism. Cube is pretty easy, we'll just skip that, and now we're gonna do one more question for cylinder. So now this is our last EP square, and we're gonna finish it up quick. This is a cylindrical shaped question, and let's read it first. A cylindrical water tank has height of 8 meters. So we know the height is 8 meters and radius of 3 meters. So not the diameter, but radius of 3 meters. The tank is open at the top and has a solid base. So it's open from the top, there's nothing on the top, but it has a solid base. What is the total surface area of the tank that needs to be painted? Now if the top is open, we can't paint there, so we need the curved surface area and the bottom part. So if this is a cylinder, this is our water tank, and the height is 8 meters, and we know the radius is 3 meters. So we do know that there is no top. We need to find the surface area of the curved part and the circle at the bottom. So same, there are two ways. You can either take the total surface area and then remove the top part, or take the curved surface area and add the bottom part. So you can try both of them just for more practice. So if we need total surface area of water tank, we need total surface area of cylinder, and then we can subtract the top part, because the top part cannot be painted, and it says that we need the total surface area of the tank that needs to be painted, and if the top part is open we can't paint it. So we know the formula for a cylinder is 2 pi RH, this is our curved surface area, plus, and then when we put top and bottom two circles, it's 2 and then pi r squared. So this is our total surface area for one cylinder. This is our formula, and then we need to subtract the top part. Top part is a circle, so pi r squared. Now this is what our formula is. Now we can put our values in it. So this circle is getting subtracted and two circles are getting added. So before putting the formulas, you can just take one out. That just means we just need to have 2 pi RH plus pi r squared, which is basically the curved surface area and the bottom part. So now what we have is 2 times pi is 3.14 is 6.28 times the radius is 3 times the height is 8, plus, since one 0 pair is cancelled out, we just have 1 pi r squared, which is basically, we can just put on the values, 3.14 pi r radius is 3 and 3 square is 9. So this is our formula, putting values in. Now 3 times 8 is 24 here, and then 9 times 3.14 we can just put it on a calculator, because doing it on a side is gonna have a little longer calculation. You can try it on a side so that you get better at more calculations. 24 plus, and this becomes 28.26, and then this comes down the same, 6.28. Now according to BEDMAS, we need to multiply these two first before adding this. So if we put it on a calculator, we get 150.72 plus 28.26, and if we add 28.26 to this, our final answer, which is our total surface area for water tank. Remember, not the cylinder, because we already subtracted the top part, which is not getting painted. So the total surface area of water tank that needs to be painted comes 178.98. Sorry, 0.98. And since they gave us that it's in meters, we have to write meter square. Never forget to put all the units, because units can make you get less grades in your tests, or sometimes in PATs like part A. So this is our answer for this last question of the day. Thank you for watching this video. If you want to see more videos like this, make sure to hit that subscribe button and turn on the notification, because you don't want to miss a single lesson. Keep building math your favorite subject, starting every single day.